Hi everyone, so it's Coach Fred, and today I'm going to be going over exponential functions and the rule of 4. And you know how big I am on this rule of 4, understanding a function many different ways. So today we looked at symbolically a function of the form y equals ab to the x. And we actually called this an exponential function. We call this an exponential function. And we learned that in this form, that b was the base, and a was the y-intercept. And x is my input, y is my output. Now, there are other forms of the exponential function we're going to be talking about in future lessons, but today we're going to focus on this one. B told me whether or not, if B was less than 1 but greater than 0, it told me that it was decay. And if B was greater than 1, it told me it was growth. So when we look at an exponential function, we're going to want to be able to identify that. We're also going to want to be able to picture it graphically. So graphically, we looked at it. Here's our XY coordinate plane. So graphically, growth is going to look like this, something like that. And it's going to have an asymptote going through the x-axis. Whereas decay is going to be falling as it relates, if it goes down like that. Sorry, my curve's not perfect. And it's going to have, again, a horizontal asymptote at y equals 0. So we're going to want to be able to graphically picture what's happening. Numerically, I want to talk about numerically for a second. If I were to make a table for this function, okay, so y equals 5 times 2 to the x, okay, sorry, like that. My table might look like 0, 5, 1, 10, 2, 20, 3, 40. I want you to recognize what's happening in the table. On the x side, all of the x's are increasing by 1, while all of the y's are being multiplied by 2. That's because in a exponential function, the rate of change is not constant. The rate of change is a percentage or a ratio, okay? It's a percentage or a ratio between terms, a common ratio between terms. Common ratio, meaning 10 divided by 5 is 2. 20 divided by 10 is 2. 40 divided by 20 is 2. So I actually could get another point on this graph. I could work my way backwards to -1, which would give me 5 halves. So numerically, that's what's happening. Numerically, we could also look at an exponential function as a sequence, which is where we started our whole investigation on this, with looking at a sequence of numbers. Now remember, a sequence we could turn into a table noting that, like, the term number, okay? And if I put ... at the end, that means it's going on forever. So this is an exponential sequence. We actually refer to this as a geometric sequence. And we're going to talk more about that. Effectively, we could say maybe something like this. A population of 5,000 bees. And I'm letting 5 in this case be the 5,000. A population of 5,000 bees doubles every month, where x is months and y is the total population. Descriptively as well, I want you to notice that the ratio between terms is constant. okay? The ratio between terms may be the y values, okay? And that's how we can look at an exponential function. We're really going to dive very deep into this function because I just think it's a really fun function to play with, especially now that we're talking about how COVID exponentially grew so quickly this past year and how we'd really love it to exponentially decay. I think we're getting there. We're getting there. We're going to be there soon. Anyways, okay, so that is more about exponential functions and the rule of 4. And again, like I said, we're going to go into more detail. This is just a basic, help you get a basic understanding of it. All right, guys, have a great day.